Okay. Okay. Hello. Good morning to everyone, and welcome to this first international workshop of VERA Project. And we are very happy to have you here. Let me give you just a brief instructions. We would like you to make your questions and answers not through the chat, but through the button you will find on the right hand side that is questions and answers. Please, if you want to make any question to anyone, please write down there your name and your question, and we will try to handle all the question and answers through that button, not through the chat. Okay, the chat is for saying hello. So thank you for being here. My name is Jaime Rivalaigua. I am the CEO of Meteogrid, the coordinator of the VERA project, and I will provide you firstly the agenda of the workshop today, and some words about the presentation of the project. Let me share my screen so you can. Okay. Can you see my screen? Is it okay?
Yes, we do.
Okay. So, as I mentioned, thank you for being here. This is the agenda we are planning for today. Firstly, the Portuguese time and then the Spanish time. So, welcome project presentation that I'll do. Then we will talk a bit about the VERA pilot areas. Then we will talk something about the technical approach, vulnerability, and so we will present you briefly the tools, the platform, the VERA platform. Then we go more in detail with synergies and complementary with other European projects, and we will leave some time for debate and for wrap up and closure. So this is more or less the timetable we will follow. Let me introduce you the VERA project, just to let you know the main figures. The starting date in February this year, with a 24 months duration in this call, and focusing on in the topic of knowledge for action in prevention and preparedness. This is the budget and the contributions, the European contribution. We are 7 partners. Meteogrid is the coordinator. ADAI, Universidad de Aveiro, and Universitat Politècnica de Catalunya. We are, let's say, the partners more devoted with research and development, but we also have 3 partners more focused on management, on different aspects of management, that are Protección Civil de Catalunya, BOST, Portugal, and de Valabres from France. So we are 4 Portuguese partners, 3 Spanish partners, 3 Portuguese partners, and 1 French partner. Let me tell you that this project VERA is, let's say, a continuation of VESPRA project that was focused in Spain and Portugal, and that was funded also by DG ECHO. Also, the project expanded in 2020 to 2023, and in that project we began the development of the platform with a protocol for the collection and standardization of vulnerable elements, a collection system together with a geographical database to integrate those vulnerable elements, and the application of vulnerability models for different natural and human-induced hazards. And finally, we made some international training exercises to test the results. This is a photo for the last one that was quite a lot of people attending. Let me also tell you that as results of this first version of the project, we already have the grid converted it into operational services that we are providing to different users, in this case, the autonomous community in Madrid and in Murcia. We will show you later. And we made some other applications of the same idea of the project, with projects for cooperation for development in Nicaragua and also for European projects, and with applications to other European projects in climate projects. Let me highlight that the context in which we are regarding climate change. Unfortunately, these are photos from the Dana, the big problem we had, the big emergency we had in about 15 days ago in Valencia, here in Spain. And this makes us reflect, thinking about what is happening, that these extreme events are presenting each time more frequently. So we have to pay a lot of attention to what's happening and trying to move in the project towards giving as much as possible answers or helping to give answers in regard to what's happening, what we are seeing is happening. So we all have clear that we need emergency planning tools, but in this climate change context, this is even more clear, no? So we have to try to incorporate to the project, as I mentioned, lesson learned from these catastrophic events, and we have to learn from this, trying to adapt the tools we were planning to provide, to develop, so they can provide valuable information for this kind of disasters. And we have to strengthen the attention that we were already thinking about, to pay quite a lot of attention regarding population. So with these kind of events, we see that we have to pay even more attention. So this has to teach us that we have to focus very much on population, because it's really crucial. And we have always to have into account, although this event was not transborder, that the cross-border scenarios occurring in quite complex environments with different approaches and different on how do they calculate vulnerability, and different emergency protocols that are, as I mentioned, different in the different countries. So the approach with cross-border emergencies is even more difficult and has to be involved, of course, in this project that aims to focus there. Let me show you small real images. This is a service we're providing, as I mentioned, to the region of Murcia, and this is the information with a platform similar provided, combining vulnerable elements with the flooding areas projected. In this case, it's a return period of 500 years, very big one. And let me focus on the city of Murcia, and you see all that is in dark blue. It means that more than 2 meters of flood height is expected in this return period. So as you may see, we are there. The situation is really critical, and if we have a disaster, it will be a lot of population, a lot of vulnerable elements affected. And I want to point that these are flooding depths calculated for past climate. I mean, it's calculated with observations of a period in the past. But that climate change is showing that very, very probably these extreme events will be more frequent and more intense. So we have the challenge to recalculate all these flooding areas, not with the present or the past climate, but also with the future climate, and then incorporate these flooding areas, expected flooding areas, of course, with some uncertainties, and we always manage different scenarios in the future, but to integrate them with the vulnerable elements, so we can see not what was the problem, but what will be the problem in the future. This is very important in the context. I wanted to highlight it in this beginning of the project. Just very briefly, the objectives of VERA, we mean to develop and improve risk assessments by incorporating these cross-risk effects. I mean, not only attending, like in VESPRA, to independent risks, but trying to combine them and see the risk, the cross-risk effects. Also, with a better cross-border and cooperation of the responsibles of civil protection, incorporating new methodologies for the assessment of the vulnerability, including artificial intelligence. We will see in detail after, and integrating, as I mentioned, these multi-risk approaches. As I mentioned, we have as one of the objectives to improve communications and others, take into account the specific population needs. And also we mentioned we want to make practical application of all the results of the project with training with disaster risk managers. And so let me, well, we will see later on in detail the two pilot cases, one in the border of Spain and Portugal, and the other one in the border of Spain and France. We will see details just in a moment. Very briefly, the project workflow, the first work package project management that includes all the others. Work package 2 regarding the extension of the intervention area to new areas that were not covered in VESPRA. Work package 3 is regarding the platform, enhancing the VESPRA, the platform that was developed in VESPRA. Work package 4 is this inclusion of the multi-risk approach that was not also included in VESPRA. A work package devoted only to communication, and a final work package 6 that is focused on integration and evaluation with these practical exercises and so. And we have also work package 7 regarding dissemination, communication, and exploitation. Well, I finish here because these slides are just to show you the pilot cases that will be explained right now. Regarding the vulnerabilities, we will also have a presentation from Miguel regarding how do we deal with this. The platform will be also presented by my colleague Emilio, and that's all. So I only wanted to present you the project, and I give the word to for presenting you the pilot cases. I finish sharing my screen. And you are muted. Now.
Okay. Good morning. Can you hear me now?
Yes, we can hear you.
And the presentation, can you see it?
You can see your screen, yeah.
Okay. So my name is Alba Águeda. I'm from Universitat Politécnica de Catalunya, and I will present you briefly the pilot areas where we are working within the VERA project. I will start with the area that we have defined between Spain and France. And this is a map where you can see selected the regions where we are working. In the border of France, we are considering the Pyrenees Orientals area. It's a NAT3 area. And on the side of Spain, we are considering three comarcas. We call it like this in Catalonia, which are Ripollès, Garrotxa, and Alt Empordà. They all belong to the Girona NUTS 3 region. And regarding the three main types of accidental events that we are considering in the VERA project, which are the wildfires, the meteorological events, and the industrial events, also considering nuclear event scenarios. So if we focus on wildfires, you can see here in the map in the middle of the slide, data extracted from the European Forest Fire Information System database about the fires that have occurred in the area of interest. You can see the fire from Alt Empordà that was near the highway that we have between France and Catalonia. And you can also see on the right side, you can see the for both areas, Pyrenees Orientals and Catalonia, you can see the risk and the hazard associated for the municipalities in these regions. You can see, for example, that in France we have more or less 1/3 of the area that has between a high and a moderate risk. And also in the region of Catalonia, we also have several municipalities with a hazard much higher than the average, considering the whole Catalonia, and also with a hazard much higher than the average. You can see that the municipalities close to the border, there is a group of municipalities close to the border with a hazard much higher than the average. Regarding the meteorological events in this map, you can see plotted the events that have been introduced in the database of the European Severe Weather from 2020 to 2023, related to heavy rain, heavy snowfall, large hail, and severe wind. And you can see that for our area of study, we have this kind of events. And you can see that, for example, severe wind is important in France, in the French side, but also the large hail events. This area is also characterized by Mediterranean episodes of heavy rain and flooding. And recently, we are living like a situation of hydrological drought also in the region. And according to the European Environment Agency, the heat wave index for both regions, for the Pyrenees Orientals, is 0.5, and for Girona, which is not exactly our area of study, it is 0.3. So it's not very high, but it is to take. We need to take this into account also. Regarding the other type of scenarios related to the type of accidental scenarios in the industry, this map is extracted from data published by Planas et al. In 2023, and this is showing the industrial areas of the area. This is a map that has not been validated, so this will be validated in these specific areas accurately, because this was a map that was generated considering OpenStreetMaps. So we will have the opportunity to validate this data, and you can see that the whole area is not very industrialized, but there are some hot spots where some industries are present, and there are also like these two spots here in red that are Seveso sites. So in both countries we have one site which is considered a Seveso site. In the French side, there is the Titan Noble Society, which is manufacturing and distributing explosives for industrial purposes. And in the Catalan side, we have the parking facility for hazardous materials from Adif in Portbou. So we have these two different type of sites. Regarding what Jaime was mentioning about the vulnerable elements that we have in the areas of study, in this area, in this pilot area, we are lucky because we have two partners in the project that are working for civil protection and for emergency analysis. And so we are asking, they are providing basically the data related to the vulnerable elements present in the pilot area. So in the Catalan side, Protecció Civil, and in the French side is Balabra. And they are getting data from different sources. For example, in Catalonia, they are providing data that they are generating by themselves. So they are providing cartography produced by themselves, but they are also compiling data from different institutions of Catalonia. As an example, from the Water Catalan Agency, and also data from the Spanish Ministry. And from the French side, we are collecting data from the vulnerable elements in the pilot area from this database that you can see here. And yes, this is basically the source of our data about vulnerable elements. Regarding the Spanish-Portuguese pilot area, in this VERA project, we are considering these two main regions, the Alto Tâmega-Barroso region, which is also a NUTS-3 area, and the Orense NUTS-3 area in Spain. Both areas, as you can see, are fire-prone because of the type of vegetation, the type of topography that they have, and the climate. And you can see in this plot, as before, the data about the fires that have occurred in the region, according to the European Forest Fire Information System from 2008 and 2023. So you can see that there are a lot of fires in this area. Regarding the meteorological events, in this plot, I am also showing the events related to the heavy rain, the large hail, and the severe wind that have occurred in the pilot area from 2020 to 2023, according to the European Severe Weather Database. And you can see that this is also an area where we have heavy rain and severe winds. And related to the industry type of accidents that we may have to consider in this area, I have also plotted here the industrial areas that were obtained using the methodology published by Planas et al. For this region. And I just want to also show, related to the fact that we need to validate this data, that, for example, in this pink area, in this square here, you can see that there are some industrial areas that are somehow obtained by Planas et al., but there are some other industrial areas on the right side that were not obtained. But according to our to CIMAT data that were provided to us, I will explain you later, these are also in industrial areas, so we will have to consider them also. So we are now in this step of validating all the data that we have been gathering. Another example here on the right side is related to the fact that according to Planas et al., in this green square, there was an industrial area, and you can see it also from Google Maps view, but according to CIMAT data, this is not this is not important to consider. So we are now in this step to take a look to all this type of data. So as I was mentioning, for this area, we are gathering data about the vulnerable elements from CIMAT, from the Comunidad Intermunicipal do Alto Tâmega e Barroso, and we have already signed a collaboration protocol. They are not partners of the project, so this was one of the steps that we had to do first, to sign this protocol. And for the Spanish side, we are now on this step. We are finishing the signature of the collaboration protocol with the Dirección Xeral de Defensa do Monte. So regarding the sources of the data related to the vulnerable elements in Portugal, we are analyzing data from this Observatorio do Alto Tâmega e Barroso. This is from this website. And we are also getting information from the CIMAT partner. And because they are, as Protecció Civil, they have their own cartography, so they are providing us this type of information. And once we have all this information, what we have to do is to try to homogenize the available data. And we are now considering this type of characteristics to compare the type of geometry, the coordinate reference system that they are using, the fields, and the type of information that they are including for each type of vulnerable element. So just to show you an example, for the Catalan and the French pilot area, for the primary schools type of vulnerable elements, we have different type of information because Catalonia is giving us point information, France is giving us polygons, and they are both considering different type of fields. So we are trying to homogenize this. Also for the Catalan and the French pilot area, this is also an example. You can see here that for the type of vulnerable element related to the roads, Catalonia is providing us a kind of one single type of roads with 11 different type of fields for this type of elements. But from the French side, we have 3 different types of roads. And as you can see, 3 of them have 12 different fields, and one of them has 83 type of different fields. So this is a lot of information that we will have to somehow integrate, homogenize into the VERA platform. And you can see here an example on the right side of the screen. This is the road in red color is from the Catalan side, and the roads in this gray color is from the French side. So as you can see, France has information about very small kind of roads that we don't have so far from Catalonia. So these are the kind of differences that we are encountering, and this is somehow the type of challenging work that we are doing now. regarding the homogenization of the available data related to the vulnerable elements. And that's all from my side. Thank you for your attention. And if you have any questions, I will be glad to answer later. Thank you.
Thank you, Alba. Jaime, I think.
Okay, then yeah. Now is you, Miguel, who is no? Is yes, is you, Miguel, who is presenting? No.
Yes.
Okay.
So just let me put my screen. I think you can.
I see you, but not your
See my
screen.
screen? Yeah, great, and hear me perfectly. So, good morning, everybody. You cannot see my screen?
No, we see you.
Oh,
We see you,
sorry.
but not your screen.
I will try again.
Now we see
You
your
can?
screen.
I do it. I did it again. Okay. Is fine now?
Dime.
Okay.
Dime.
Very well. So I will talk a little bit about our the approach that was the technical approach that was followed in VERA. And so I will divide my presentation in two components. The first is to talk a little bit about the database on vulnerable elements that somehow was introduced by Alba in the previous presentation. And then I will talk about the approach that we followed to map the vulnerability, how did we approach the vulnerability, somehow preparing the stage for the presentation of Emilio that will follow my presentation. Once again, Alba already told, but these photos that are in here somehow highlight that this project addresses mainly four hazards. So it's the wildfires, the extreme meteorological events, mostly the floods, industrial accidents, and within the industrial accidents, the nuclear accidents. So starting by the database, so at the beginning, still in the VERA project, what we realized was that there were no databases in the state-of-the-art European databases on vulnerable elements, but addressing all the hazards, all the hazards that are addressed in the project. So some databases were focusing in one hazard, but not in the four hazards. And so we start constructing our database. And so our database have several levels. The first level so only has 6 clusters, let's say. So it's about people, essential services, commerce and public service facilities, industrial facilities, environmental elements, and cultural facilities. So this first level open in a second level that, for example, for the people, so we will have there the individuals and residential buildings. Then, for example, the basic services include the educational facilities, healthcare facilities, and so on that you can read in here. So let's say the first level opens in this second level that you can see in here. And then we still have a third level that is, for example, in the, I don't know, for example, in the second, the basic services and the 2.3 power and energy systems, we will divide it still if these infrastructures are for electricity, hydrocarbons, or whatever. So we still divide in the third level. And in here we have all the elements, all the potential vulnerable elements in a certain area, as Alba showed before. And each of these elements can have attributes that can be populated, so that can be available or not. For example, when we have people, we can have the age, or if that those persons that are in a certain area, if they have some kind of disability and so for civil protection, they can have a specific or special needs, for example. Of course, I would say that is almost impossible to have all the attributes for all the elements, for all the people in a certain area. But when we have it, so we can include it in the database. After talking about the database, so I can start talking on vulnerability and how did we approach the vulnerability, the mapping of vulnerability in VERA. And first of all, I would like to talk about what is vulnerability, because sometimes people do not have clear what vulnerability is, or at least what is our concept in VERA. Vulnerability is a function that relates the degree of loss with the severity of the hazard. So it's a function like that. Of course, that we can imagine how difficult would be to find a function of vulnerability for each of the elements that are in the database. And so, because it's very difficult to have this function, we simplified, so considering different classes of vulnerability, so 3 classes of vulnerability. And so for each of those elements, for each hazard, we can say that the vulnerability is low, medium, or high based on this simplified function of classes. And so what Emilio will show you after is so the tool itself, but this is the algorithm of the tool. And in this algorithm, we have here, so the dynamic information. So the inputs are in green in this scheme. So, and the inputs are, first of all, the dynamic information with the date and time. Of course, they are dynamic, as well as the meteorology. Meteorology is changing very fastly. The fuel moisture content, for example, for the wildfires, and many other input parameters that change with time. Then we have another group of information of inputs that is the static information. For example, the elements at risk that belongs to the, or are related to the database that I showed you before. The terrain model, for example, is something that is static. Also, the fuel models, the land use somehow changed, but not so fastly as the dynamic information, and also all this information. Then we have the value classes and the vulnerability classes that I will explain later. Also, let me tell you that in this dynamic information, so it's something that is in the middle, is the population, because it's somehow static and also dynamic. And why dynamic? Because in this VERA project, we will address these very important vulnerable elements that are the crowds. For example, we can have groups of people so moving from one side from the others and changing. For example, imagine if there is a hazard event, of course that people will be concentrated in, crowds will be concentrated in a certain area. Or for example, if we have a fair or a festival or something, so there will be in that part of the map, we will have crowds of people, and of course the civil protection authorities must know that they are there. And we will address this specific element at risk based on crowdsourcing. Actually, our colleague Jorge Vost would present this part, but he had a medical issue, and so he will not make this presentation. I'm sorry for that. But so basically, I can tell you that we will detect where crowds are based on this crowdsourcing. What is this crowdsourcing? Crowdsourcing is basically the number of the clouds of messages or activities on social networks like X or Facebook or wherever. So all these activities will be measured, and so we know that there are crowds or many people in these areas where those messages or that activities are being developed. And so we know that there are many people there, and this is a methodology that was previously approved by the European Commission, because does not go against the rights, the individual rights, because we are just following up the crowds and not the individuals. Anyway, so after to talk about this, all this input information, so we will have within the model, we will have these hazard models for each of the hazards that I mentioned before. And these hazard models will provide us the spread of the event, of the hazard event, and the severity. And based on that, so it's possible to have these inputs, to take these inputs, so the area affected by the event, the potential damage classes, and the potential loss. That is something that I will explain later. Now I will talk about these value classes, because it's something that is not direct, so it's not those direct elements. And the value classes, we divided the total or the integrated value of the elements, we divide it in partial values. Basically, the economical values, the ecological, the cultural, and the social values that is associated with each element at risk or vulnerable element. And so, for example, for the economic values, we said that, okay, if the economic value is below 100,000 euros, so the value is low. If it's higher than 500,000 euros, the value is high. So always in these classes, low, medium, and high. In terms of ecological value classes or the cultural value classes, we define, so if that specific element has a local, regional, or national interest, so we will define if its value is low, medium, or high, the ecological and the cultural. Regarding to the social value classes, this is a little bit more complicated, but is something related to, once again, to the local, regional, or national interest. The number of jobs that are provided, imagine, for example, that is an industrial facility. If the inactivity of that element causes local, regional, or more than regional disturbance, and also the number of people that affects, if it's a family, a community, or more than a community, if we lose that element. And so based on these partial value classes, we can have the combined value classes that is what will be mapped. And so, for example, if the impact of that, so the destruction of that element puts in danger human or animal lives, so of course the value is high. If it's a critical or a strategic element, also the class value is high. If in those 4 partial classes we have 2 or more elements which the partial value is high, so we say that the combined value is also high. Otherwise, we will make an average of the partial values to have the combined value. So this is, for example, this is an example. So for a commercial and services facility, for example, the ecological value is normally not high, so do not have ecological value. But then we have the different partial classes, and we make this average of the partial classes, the values. And so once we have this for each of the elements, we can have, I know these pictures, these images are quite basic, but I think it's very easy to understand what is the approach that we follow it. And so that's here we can see, for example, what is orange, green, or red. We can see, okay, we have in this map, in this area of interest, we have these values with more or less combined value classes, these elements. And then we can run the hazard event. Imagine, for example, a wildfire, because it's the example that I have in here. We can simulate for planning purposes, or because we have an emergency situation, so for response phase, we can run, we have, for example, an ignition in here, and we can see that the fire can spread in this line, dotted line that I'm showing to you. And so this will be the affected area. And of course, the model also can provide us, based on the topography, based on the full models and so on, the full maps, we can have the intensity that is expected in each area. Of course, this is very raw. We do not have such large spots, but it's just for an example to be more understandable. So we already have the affected area and the severity of the hazard. And so this is what is here. So we'll talk about the dynamic information, static information, the value classes, and the hazard models. Now I will talk about the vulnerability classes. And so once again, I remember that we approach the vulnerability class, the function of vulnerability in terms of classes. And for example, this is the vulnerability of a building related to the wildfire. And so we can have here the level of destruction and related to the fire intensity. And so what are the classes that we assumed to be high, medium, or low vulnerability of these houses related to the wildfire. And so once we know, for example, all the buildings, of course, that this can be changed in the tool. But so once we have all the elements mapped, as I told you before, and we know what type of elements they are, for example, buildings or trees, whatever. So we can have in here the potential damage that is expected if there is this fire event, because we know the intensity. So once again, we can come here to this graph. Okay, the intensity, for example, it's 7. So the degree of loss will be high, for example, for a building. And so we painted a building in green here, for example. So we can, with this, to map the potential damage expected for each element that is mapped and that is within the area affected by the hazard. And so, of course, that we can have in here, we can have the potential damage, but we do not know if the damage is in a building that has a high value or a low value. And so it's important not only have the potential damage, but actually the potential value loss. And so for that, we built this matrix in here. So once we have a potential, a low or a medium or a high potential of damage, and the value is low, medium, or high, we can cross in order of having the potential loss. Actually, here the title is it's not correct. It's European database on vulnerable elements, but should be the potential loss. And so crossing that, we can have the mapping of the potential loss is higher in terms of all the elements that are mapped there. And with this information, we can understand, for example, if we are talking in the response phase, so if we are in emergency situation, we can see that the green, the red elements are those where the allocation of civil protection resources is the priority is there. For example, when we have green, okay, it's not so relevant to send there, to send resources, civil protection resources to these parts. And so basically is this, if we are talking, for example, in planning phase, we can run simulations to see where we have more red spots, more red elements, and so preventive activities should be carried on when we have these red spots. And so basically this is the approach. And so it's, as I told you at the beginning, so it's a preparation to the presentation of Emilio that will be next. And so Emilio will show you the tool itself based on this approach. Thank you very much.
Thank you, Miguel. I would like to share my screen.
We can see it.
Yes, okay, thank you. Hello, welcome everyone. This is the presentation of the platform. My name is Emilio de Diego from Meteogrid, and I am working in the development of the platform and include all this approach and data from the pilot cases in the platform in order to create this scenario for this project and this platform. The VERA platform is an evolution of the VESPRA platform, and within the VERA platform, we had defined a specific work package to enhance the system platform by incorporating new features and requirements to improve it, the result, no? And include in the future new communication tools and multi-risk approach in the next work package that we start now in the project. And in the future, check all the results in different trainings in the area, especially in the frontiers that we are selected in the project in France and Spain and Portugal and Spain. As Miguel explained before, this is the VERA tool, and include this model inside the platform within the gathering tool in order to create two tools inside the system. We include all this catalog in the platform with different edition tools in order to create this vulnerable database and mix with the dynamic information and the static information as an inputs of the hazard models and obtain the different results in the platform. The catalog, as Miguel explained before, is basically these 6 categories and include all the catalog in the platform to gather the information. This is a video of the VESPRA tool. It is very easy to use to include a new element. We can include the geometry of the element and then the different data related with the element. And in a few seconds, we can obtain very valuable information, very useful in an emergency. This is in a map inside in the platform, and we have different tools to use this information as a geographic information system or map tool that we use in a site on the internet with these tools to manage the information. And this is the layers that include all the catalog and other reference information to manage the map, and different backgrounds and other buttons to manage the map, the zoom, measuring, searching information, download the information, or upload a map, incorporation and other auxiliary layers in the map. The gathering tool is, as seen in the video, to incorporate new elements is very easy, and it's very easy to use the manage of the information inside the map and edit and delete the elements in a complete workflow to acquire the information in the platform. And in addition, we have defined different profiles of users with different characteristics. Some can only view the information, others can edit, and others can validate the information to control the quality along the process. As Miguel explained before, we have then the obtain the information, obtain different vulnerability assessments by the element with the characterization of by the different attributes of the element, or if we don't have this data, use general information about the category of the element and classify the map in the elements in a map of vulnerability by high, medium, or low, or obtain other derived information, for example, the zonal maps with clusters of the vulnerability in sensitive areas, and combine this information in a tool for decision making. This is a short video with a simulation inside the platform, and the advance of the fire or a flood, and combine the information of the emergency with the elements, with the vulnerable elements in one map, no? And obtain results, for example, the exposed elements in the area, or categorize the elements depends on the different point of view from the emergency. For example, in a fire, using the fire intensity, or in a flood with the advance in the time. And the time is very important in this kind of tool, and include all different ways to manage this information. We have this calendar or time or timely information to check the information in the past or in the future. With these all tools, we have the meteorological assessment inside the platform and the simulation features to check or combine this information to obtain this kind of results. Inside the platform, we have a complete administration module to manage the users, the sites, the pages, the layers, legends, and change all or combine depends on the necessity in a moment or in a client. And the platform is created with an scalability and easily manageable in way to introduce new information and allow us to develop the platform in a simple way in the future with different scenarios. And I would like to show the platform. Now this is the results we can use like inside the navigator in our PC with user and password. And inside the platform, we have different menus to manage the information. This is the vulnerability map with the catalog in the platform and check the different sub categories of the elements. And inside new elements in an area that we had selected and check the information with the backgrounds or another information that we can relevant in this area. And with all this information, make other calculation, the vulnerability assessment, and introduce this information in a check the information by validators is useful or not in this emergency or in this area, and with the meteorological information or other information from different risks, combine the information and obtain results in a specific area. For example, this is a simulation of fire, and check the vulnerability information in this area with different elements by their characteristics or the positions, and check the different vulnerable elements or exposed elements for the advance of the simulation. No? This is the table result of the vulnerable elements in this area of simulation, and I can check, for example, these constructions in this time of advance of the simulation, and checking the map is necessary, and check, for example, if I have relevant information for this element, and or manage the information if it's necessary at this moment, or send the information a partner that we that he or she is in this area, and check the information inside the platform. No, this is an example with of different simulation, and I can check these warnings inside the platform to check the information in the moment of an emergency. And finally, we can obtain a complete reports about the simulation and check the different advance in the different moments of the fight in this case, and include in this report the different exposed elements in the area. And thank you very much for this. If you have any question about the platform, we can check your questions in the Zoom. And now Luis explain now the different relations and synergies the VERA project with other relevant initiatives in the European Union. Luis?
Hello, good morning to everybody. I'm going to try to share my screen. Just a moment.
Please try to speak a bit lower,
Okay.
louder, because your microphone is a bit low.
Okay, may you see my screen? And can you hear me?
Yes. Okay.
It's everything okay? Okay. So I'm going to talk about other projects that can be related with VERA. We know that in the context of the European Union, there are a lot of projects that are related with risk and to avoid to do the same things that they are doing. One of the first activities we have undertaken in the project is a review of all other relevant European projects that can be related with VERA. Okay. We have tried to map all relevant initiatives within the European civil protection mechanism, and but not only. We have we have also make a survey of other projects related with AIDS 2020 initiative in Europe, or other projects that are related with other funding initiatives in Europe. And our aim is to assess the potential synergies between them and VERA. Due to the thematic relevance, let's say the alignment with the European Civil Protection Mechanism and VERA objectives, the geographic impact, the complementarity of the objectives, if possible, the cooperation between projects, and to integrate some results of them into VERA, or some of VERA results into their platforms, or try to take advantage of previous results or achievements that have been already developed and are available in the European context. And well, the overall of our objective is to help in achieving the objectives of the European Union Civil Protection Mechanism. So we have identified a lot of projects that are related with that can be related with VERA. Some of them are here in this image, so that you can you can see here which are the projects and how can be related with VERA in this in the right side. We have identified several areas of collaboration that are risk assessment and planning, monitoring and early warning systems, communication and coordination, use of advanced technologies, training and community awareness. Some of the more important projects that we have identified are the fire risk project that is focused on studying the circumstances that affect the occurrence of extreme wildfires, taking into account socioeconomic aspects as well as biophysical conditions like vegetation and climate. And the EDERA and RASTUL projects. EDERA is a project that is focused on early warning demonstration of rainfall induced impacts and forecast, and it used the European flood awareness system, one of the Copernicus emergency management services that are available in the web. So this is EDERA, more focuses with early warning for rainfall and flash floods. But RASTUL is instead more focused on geohazards, and it's also using one of the European services, and in this case, the European Ground Motion Services. And its aim is to simplify how to use this complex information that is available in one of the European services. Talking about the risk assessment and planning, one of the main projects that are related that are fire risk and RASTUL, but there are a lot of other projects that are also related with risk assessment, and that the VERA can use to enhance the risk prediction in urban areas, but not only in urban areas, but also in the territory, using these results to improve the VERA risk management system. As we can see, there are a lot of them. Fire risk can provide a solid foundation for improving the accuracy and effectiveness of VERA risk assessments. We view models and simulations can improve VERA's ability to predict and manage risk in urban and peri-urban areas. Silvanus that propose a very large amount of new platform and solutions to base knowledge and to establish strategies for fire prevention and mitigation of fire impacts can also be very useful for VERA. CRISSAFE offers methodologies for assessing and improving the security of key infrastructure. That is one of the VERA objectives, and well, RAS tools, Safe Land, and other projects may improve the risk assessment for floods or for other hazards that are not well addressed in VERA till now. But wow, this was one of the first areas that we analyzed for collaboration, but there are other areas like monitoring and early warning. And in this case, there are other projects that are related with that can be related with VERA, and we have to analyze how we can integrate the results they have into VERA. We have already talked about Sylvanus and fire risk, but we have not talked about IWIT. IWIT is one of one project that is more focused on the extreme wildfires that are becoming more frequent with the climate change, and that are extremely dangerous because of hazardous, because their behavior is not completely known and cannot be predicted as other fires. So this is something that Hidalgo 2 is also addressing through the analysis of how the atmosphere and the wildfires interact. And there are not only the projects that are addressing the new tools for monitoring or for risk assessment, but also try to train and to raise the community, the awareness that is so important in case of hazards. In this case, we have already established some contact with Fire Prime, that is one of the projects that are proposing and generating new educational resource for local communities. And we are also trying to establish some contact with Prepare for Read and with Prepare EU, that can broaden the scope of veteran training and awareness raising activities. And as far as for communication and coordination, this is how some projects are more related with the community of people working in in different hazards. In this case, in fires and in extreme fires. Are fire risk new lead and FireLog. FireLog is an initiative that try to maintain in contact all the projects that are working in the context of fire spread, but not only the project, but also the people, the operational people, and the scientific people that are working in this area. And finally, there are also some of the projects that are using advanced technologies that can be very useful for VERA, just to integrate the results, not the technologies directly, because are difficult to integrate. So the Sylvanus, as I said before, is a project that is proposing at a set of technologies that can monitor not only monitor, but also to give early warning of possible events through the use of social information that is shared in Twitter, in X, or in other social platforms, and through the use of artificial intelligence tools, and they are able to extract the information that can be related with hazard events, and through the use of drones and satellite information, and they also can monitor how the hazard is or the event is spreading in the territory, and can also offer the decision support system to the people managing the event. Then Manifest Genius is focused on innovative solution that can provide additional technologies and methodologies to the various capabilities in risk management and emergency response, and the use of artificial intelligence, high performance data analytics, and exascale computing in Hidalgo 2 can provide a better understanding of the distribution of risk in the territory, and also to better knowledge the behavior of large fires, as well as the possible impact of fire spread and smoke dispersion in urban areas. And well, that's the projects that we have identified. We are trying to contact most of them, but till now we have just contacted a few of them, and some others, because we are some of the partners of VERA are working also in these other projects. But we are trying to contact also the the projects that are less related with the VERA consortium, but that we think that can improve the risk assessment and the hazard understanding in the VERA platform. That's all for my side. I don't know, probably Jaime or who is going to. But right now, this is a time for the debate, so you can make some questions to any of the speakers.
Good morning to all. Thank you for all the questions that we have. Emilio already answered a few questions. So there was one from Maria. How do you express severity? And I think this question should be for Miguel.
Okay. Thank you for the question. So the severity is the capacity of the process of the hazard event, so to cause harm based on the magnitude, the intensity, the degree, the speed, if it's the wind, for example, or another parameter that best expresses its destructive potential. So in terms of fires, for example, is intensity and so on. Wind is wind speed. I don't know if there is, if you want more examples, or if it's fine.
You can react in the discussion, Maria, if you need. For Stefan, Maria, so you can choose one of them. So Miguel, there's an answer from Maria, so you can choose one of them, or it's a combination.
Sorry, because I'm still opening. I was not finding. Where is that?
It's in the Q&R. Maria is just saying, you can choose one of them, or it's a combination.
So each hazard, so each element has a vulnerability curve for each hazard. And of course, that if we are dealing with fires, for example, we used the fire intensity. If we are dealing, for example, with winds, it will be the wind velocity. So it depends on the hazard that we are talking about. I cannot see where is that options. I do not know, but
it's at the bottom of the screen. Maria is just saying, I'm interested in wildfires.
So it's the fire intensity. Next page. Okay. Okay. So in wildfires, what we have done, it was the intensity. So the fire intensity in megawatts per meter of fire front that is expected. Actually, is what the tool, the simulation tool, provide us.
And how do you get this information? She's asking.
It's the simulation program, the software that provides us. The simulators, normally the simulators provide not only the rate of spread, but then it's possible to extract also the fire intensity that is expected in each cell.
Okay. So we have another question from Stefan, and I think this will be for Emilio. How is the vulnerability validated? Are there validation studies available?
Sorry, I think this question is more for Miguel, no? Is the explain the vulnerability approach in the project? If you can to explain the process in the VERA project, Miguel?
Okay, I can. I'm just trying to open. I'm a little bit confused with this question. What the question is?
The
That
question
one,
is,
sorry?
how is vulnerability validated? Are there validation studies
okay.
available?
Yeah, there are many in the bibliography. There are many functions of vulnerability. So normally we use what what was already published. Of course, that, for example, the buildings, that was the example I gave. The buildings, we have different types of buildings. And what we include by default is a function for all the buildings. But of course, for example, that the users can change the vulnerability of certain houses. So if they think that there is a specific house or building or construction, whatever, that have a specific vulnerability, so it's possible to change. So we just put common functions for buildings for each element based on the bibliography, so what is published.
I hope, Stefan, the answer is good for you. If not, just write in the chat or in the Q&A.
Okay.
For Emilio, hello, Sandro from Portugal. We can integrate any type of hazard in this platform. For example, in Madeira Island, we have many dangerous debris flow. Is it possible to predict these events or to have a more accurate perception of them using the simulation that you propose?
In the platform we are working now with in forest fires and other meteorological events, and we can check the information of these risks in this specific area, and then analyze the possibilities to include if it's possible. And this is interesting to analyze in the project, because one of the work packages is the extent of the platform in other areas. I would like to check this, and if he can send an email from this issue and check the information of the Madeira and the risk in Madeira of this of the risk, and then an answer, a complete answer by email.
But regarding the possibility of predicting these events, we really can't say nothing now. We should talk with you, with experts on this kind of events, and so we can together try to address how can we predict, or how can we assess a vulnerability to these events. So that's what we are doing in VERA and VESPRA projects, working with experts on the different hazards in order to address the vulnerability. So for this new risk, we don't have the expertise, at least MeteoGrid. I don't know, other partners perhaps in the project could, but we should work together trying to co-create a vulnerability function or simulation of the risk. So we are very happy to work together, trying to implement this platform for other risks. Yesterday I was presenting the platform in Brussels to the representatives of all the countries regarding investments in disaster risk management, and we were thinking about that, about extending VERA platform to other countries, to other areas, perhaps transforming it into we are going to try to transform it into a European service. And another point was to extend it to other hazards. So we are very happy to have this kind of questions and to collaborate, trying to include them.
All right, so Shady, you had the answer in this conversation. We have a question from Bella. Have you considered the wildfire smoke plume with the satellite data, for example?
Yeah, I can answer. Sorry, just to put the video. Yeah,
me, Miguel,
the smoke is also something that is foreseen for the VERA tool. So the answer is yes.
Excuse me, please make your questions not in the chat, but in the question and answers area, because I see that some of them are going there. For example, it was asked if we can work in other countries such as Jordan, and well, I mentioned before that was we think it could be, because when we define VESPRA, we tried to make for example, regarding vulnerable elements, a catalog that was very standardized. So we tried not to work only on hazards and on vulnerable elements that were present in that case in Portugal and Spain, but trying to make it standardized so it could be or looking for extending it to other territories. So I think that we try to define the tool, trying to cope that need. So I think we could work on extending it. And as I mentioned before, this is something that we can work together, trying to solve these problems.
Okay, it looks like there's no more question for now.
There are some in the chat, I believe.
Yeah, all
it should not be there, but actually, I would like to highlight while you see. I would like to highlight, and I don't know if you, Emilio or Jaime or so, want to talk about this, because one concern of many civil protection authorities or agencies or whatever is that of course that they do not want to have in the same command post different screens, and so they want to use everything together in the same tool. And one of the particularities of the VERA tool is that it can be adapted to existing tools in the civil protection. I don't know if you want to talk a little bit about this, Emilio or Jaime or so.
Yes. Yes.
We
The
do not need a new screen, a new computer, and everything. Please.
Okay. And here our colleague David Caballero has joined us. Also, he can make interventions what he wants. The platform was from the very beginning thought knowing that users need to integrate information in their own platforms. So we designed it fulfilling all the requirements, all the international requirements for geoinformation inter exchange. So it has been designed to integrate information from any other source that fulfills these standards, international standards, and also to share the information that is inside VERA with other platforms. So some of the users that are already using this information are using it in their own platform. So it's adapted in order to send information, as I mentioned, fulfilling all these standards. So it's something that we know from the very beginning that would be a need. Nobody needs another platform to have a different information that is not perhaps with all the information they are using for their management. So we knew it from the very beginning, and we designed the platform to fulfill that, and it works perfectly. It's very flexible and very interactive to be integrated in other platforms. I don't know if any colleague wants to say something more.
Well, good morning. I want just to drop a couple of ideas in line of what Jaime has just said. Is first of all that we have an emerging number of platforms at European scale, like Destination Earth, which are basically an interoperable ecosystem of services, data, and models into which we can create digital twins of the real world for risk assessment and decision making. I think that's the way of going by including all these systems or all these models like services or microservices in one of these ecosystems like Destination Earth. By this published subscription paradigm and using, as Jaime has told us, some existing standards for data interchange, more particularly the OGC, all the OGC standards for data interchange. But also we have to think that little by little we are focusing on sharing data in data lakes. All these are terms that are new, but they will be the standard for the future. So Destination Earth, interoperable ecosystems, public subscription paradigm, OGC standards, data lakes, and create digital twins for real world and risk assessment. On top of that, hovering all of this, we have to think that for the integration, we have some artificial intelligence tools which are taking over steadily in these systems, which make this integration much easier.
Okay,
There's
another. Sorry.
There's a question from Sarah. Thank you for the great presentation. How are you planning on maintenance of the platform in the future? Also, if the project time ends.
Okay, yes, that's something similar to another question in the chat. That is, if it's possible, are you planning on implementing this across all the Spanish, Portuguese, and French territory, or even extend it to other countries like Italy or Greece? It would be extremely helpful, since the natural hazards are becoming even more dangerous and extreme in the Mediterranean Europe. As I mentioned before, well, now we are using the results of these kind of projects like services, like operational services. For example, we are providing them to some autonomous communities here in Spain, and we are providing them integrating also online information, mainly weather information, but other information also. So with these vulnerable elements information, we join with them the information about weather observations or weather forecasts, high added value weather forecasts for next hours or days. So we integrate the risk expected for the next hours or days with the vulnerable elements and with the vulnerability of the territory that is provided by this VERA. So nowadays, we are providing this as services for different administrations. But as I mentioned, we are thinking, we were in fact by the European Union, they told us to present this new project VERA after finishing VESPRA, because they thought that it could be converted into a European service that could be provided from the JRC and from the European institutions. So that's not present. I mean, we are now focusing only on these pilot sites to make the project. but we would like, and we are going to work for trying to extend it, to implement it as a service, as a European service. Of course, with this, for this integration, well, the platform is has some automated processes to integrate vulnerable element information. So all the cartography, that is thematic cartography, that has been produced in the Europe scale, could be integrated quite automatically, but with not the deepest scale. So after that, it would be interesting to make a more detailed introduction of information from the local scale. That's something that it's also very important. We didn't mention it. Very important for VERA project. We know that vulnerable elements or defense elements that could be also included in the platform, like points where you can take water for a forest fire or whatever. These elements change very rapidly. They are something gets wrong, or a new element appears soon. So we have to be able to update the information that is inside VERA very quickly. And for that, we thought from the very beginning to make a very, very easy to use platform that could allow from the very local, from very non-expert users in the local administrations to make this update of the information. So we are already using this, as I mentioned, for example, in Madrid. We are using it in very, very small towns that have many, very few personnel in the town hall, and that they are at all technical people, but it is so easy to use that they can very easily adapt this and update this information, and that would be a second step, let's say. So we could make this a European service, and after that, it would be very helpful that local or regional or administrations could interact with the platform to update this information and to provide more details that make the platform more useful. I don't know if it's clear.
May I add something, a small remark about this, all this multi-scale data management, which Jaime is referring to, which is super useful. But the problem is that there are some problems, or at least some challenges, for this multi-scale management, data management and modeling, which is to ensure the spatial and temporal coherence. For that, you have to understand that we have several models, several services, each one using different spatial and temporal resolutions and data and so on, which is why I insist in these existing platforms or interoperable ecosystems into which inject our services, because they offer an overarching framework in terms of spatial and temporal coherence, particularly when we are coupling models, as we are focusing in. So this, I think that's interesting if we little by little are injecting all our services into these big platforms like Destination Earth.
So answering also Raquel Paula's question, well, we are going to try to implement this to the whole Europe as a European services, and we are also open to make collaboration for developments in other areas or in specific areas of Europe. We can collaborate in research projects or development projects or providing it as a service, as I mentioned. So we have done it in different places. For example, we made an application, a small application of some of these regarding other hazards like landslides in volcano areas in Nicaragua, in Isla de Ometepe. So within a research and development, the development Cooperation for Development project funded by Spanish cooperation. So as you imagine, the users are not very technical, and we can adapt the solutions for different kind of users. So we have made some applications, and I think everything was thought trying to be very flexible to make these applications in different parts. So we can talk together to try to check each case, how could it be developed before we manage to make it a European services at a European scale, if you are interested. I don't know if Miguel or Luis Mario want to add something about that.
No, thank you. Just to tell that, for example, our pilot sites in the VERA project are for transboundary regions, because it is the goal of this call where VERA is included. But as was mentioned before, so it's not only to be applicable to transboundary regions. It's, let's say, in everywhere.
I would just like to add something. It is Frédéric from France, from Valabre. Just to say that as you have seen during the presentation of the project, there will be 2 pilots, and that the pilot between Catalonia and France will be really civil protection oriented. And that it will be one of the place to see the validation of operational validation of one part of the platform. I think it will be important in order to show how the platform can be used during operational activities by fire brigades and some authorities. Thank you.
Okay, there is no more question in the chat and in the Q&A.
Okay. Okay,
I think not.
then I think we could wrap up and conclude the meeting, shall we? Or
Jaime, if you want to comment the another issues that
okay,
you can talk.
we can.
Share.
I prepared, or I would like to show you some of the slides that we presented yesterday in the European, but just the wish list, just to let you, to confirm you what I mentioned before. Let me find just a moment that we already are thinking about this extension both to other countries and to other hazards, and also trying to convert it as a service, as a European service. Let me show you just a moment. I share my screen just to comment you what I was mentioning that was presented yesterday. Oops. Can you see my screen?
Almost, but not yet. No, we can.
Okay, so this is what I presented yesterday as wish lists. After I said after finishing the project that it will end in January 2026. Perhaps we will need some couple of months more, but mainly we have in mind those dates. We would like to extend the intervention to other areas and countries. As I mentioned, the standardization we try to include in the catalog of vulnerable elements was because of this, was thinking of this. We also would like to extend it to other hazards, as was mentioned by Madeira colleague, and to integrate it as an European services, as I mentioned, the collection of vulnerable elements is quite automated. And also, I also mentioned that we would like also to continue providing and to improve these operational services that are more specifically adapted to each administration needs, and that, as I mentioned, integrates these real-time weather observations and forecasts. No, well, there are more issues related that was mentioned yesterday related this because of the disaster that occurred in Valencia, and some of the problems came because of the not very efficient communication of risk and alert to population. We also were talking about that we have to think about these issues, how to improve these alerts and communication to population, how to integrate their position in the emergency, we have a lot of things to think about and to give solutions, because that is a very important part of the emergency, of the impact of the emergency. Our platform, the project began in February this year. We are working on these population issues, but they are not already integrated in the project. In fact, we integrated BOST Portugal, that is a very expert on these issues. We had not this kind of population experts, let's say, in VERA Project, and we realized, and both the DG ECHO of the European Union told us that it was very important to integrate this point of view about population, and that's why we integrated BOST as a partner in the project, and they are working hard on these issues, and hopefully in the next months we'll be integrating this kind of information. But it was also mentioned yesterday that this has to be very important in the platforms, in the projects we are developing. So that from what we talked about yesterday with all the representatives, they talked about other projects, but they really gave us quite a lot of let's say importance with VERA Project. We were only 4 projects, 4 European projects selected to present, and they were very interested in the line we are working on. So I don't know if you have any more questions or. Okay. Then, to wrap up, I think we have presented you with quite a detail the project and the tool that we are developing in the project. We have highlighted the points that we are paying attention to, this vulnerability assessment with a multi-risk approach, trying to integrate these new methodologies, including artificial intelligence. This important issue regarding cross-border issues, because as I mentioned, each country has their own protocols and their own vulnerability assessment or concepts, and it's very important for these hazards that cross the borders easily to have common homogeneous approaches. So it's also quite a problem and very important to work on this coordination, cooperation. We also mentioned this very important pay attention to population issues, to their needs, their education. We have to make much more efforts on this educational and training population on how to react on these events. And unfortunately, what happened in Valencia is a clear proof of that. And also I also want to highlight the importance of taking into account this climate change, that we have to work with hazards, thinking not only on present climate, but also in what all the models are agreeing to say about the future, that are more intense and more frequent extreme events. So all the hazards that are related to this climate information, like for example, and very importantly, floods, we have to work with future climate. We have to obtain these climate simulations in a robust and scientific, robust way, and we have to calculate the return periods or the hazards. Not only, of course, we have to work also with present climate, but not only with present climate, but also with these future simulations. That's something that well, we have a lot of work to do with this, because, as you know, future climate can be defined exactly. I mean, we have uncertainties, and it's not easy to work with these uncertainties, but it's a need. We need to work. The image I show you, that was for a return period of 500 years. Perhaps in future climate, if we attend to present and next future climate, it could appear in much less years. So it could be something that could affect very much the planning of our disaster risk management. So this is important to have also in mind. I don't know if my colleagues want to highlight any more. Well, regarding the question and answers time, we told you that we are trying to extend, or we would like to try to extend the areas of intervention, the hazards to be attended, and to incorporate it into both European global service, and also trying to go on with these specific services for areas, for autonomous communities, for regions, for provinces, or for wherever could be interested. And I think from my side, that could be the wrap up of the meeting. I don't know if my colleagues want to add something else. Okay.
It's fine.
Then, just to give you thanks, we have been a lot of people around, and so that more than 200 people were attending. So it's a great pleasure for us to have your interest, and we are completely at your disposal for contact us, for trying to work together in other initiatives to apply this in other places. And we are really open to work together with you. It was mentioned if we could provide information about the project also in the question and answer. We will try to provide you. Anyway, we have information of the project in the European Knowledge Network, and we can send you or provide you some links where you can have more information about our social networks and so. And any question, please send us your question, and we will try to answer. So thank you very much, and good day.
Good day. Thank you very much. Bye bye.
Thank you very much.
Thank you.
Bye.